So there are few questions asked about crystal structure in the previous year questions. Before trying to solve those questions, let us understand this table that I have made, according to which we will try to solve a few questions. So we know that there are three types of crystal structures: simple cubic, BCC, FCC, and there is another structure known as hexagonal close packing structure. The first row is about the atom per unit cell, which is 1 for simple cubic, 2 for BCC, 4 for FCC, and 6 for HCP. The second row tells us about the relationship between the atomic radius r and the lattice parameter A. A is equals to 2r for simple cubic, root 3a equals to 4r for BCC, root 2a equals to 4r for FCC, and a is equals to 2r for HCP. The next column is about the nearest neighbor distance. Nearest neighbor distance is nothing but the distance between the center of the two atoms. If this is one atom and this is another atom, the distance from the center of the two atoms is known as nearest neighbor distance. If we consider this length as A, then this is R and R. Then basically A is equals to 2R. This is for simple cubic. That is the nearest neighbor distance. A is equals to 2R is equals to A for simple cubic. For BCC, 2R is equals to root 3A by 2, and FCC, 2R is equals to A by root 2, and for HCP it is similar as simple cubic, 2R is equals to A. If you remember this relationship between A and R of the different crystal structures, if we divide these by 2 for BCC and FCC, if we divide this by 2, we will get the nearest neighbor distance. Like if we divide if 3a is equals to 4r, if we divide by 2 on both the side, we will get root 3a by 2 is equals to 2r. 2r is equals to root 3a by 2. Similarly for FCC. The next row is about packing fraction. The packing fraction for simple cubic is 52% or 0.52. For BCC it's 68% or 0.68. For FCC it's 74%. FCC and HCP has same packing fraction of 0.74 or 74%. So the packing fraction of FCC and HCP is larger compared to BCC and simple cubic. Next is the coordination number or the number of nearest atom. Coordination number is also known as the number of nearest atom. For simple cubic, the number of nearest atom is 6. For BCC it's 8, and for HCP and FCC it's 12. If you remember this table and remember these values, we can solve some questions asked in the previous years. So if you look at this question, the nearest neighbor distance 2r in the body centered cube. The nearest neighbor distance 2r for BCC. The nearest neighbor distance for BCC is 2r is equals to root 3a by 2. So the answer is root 3a by 2. Which one of the following pairs of the crystal have the same packing fraction of 0.74? See, the packing fraction for FCC and HCP has the highest packing fraction of 74% on 0.74. So FCC and HCP has the same packing fraction as 0.74. The packing efficiency in the crystal is maximum 4. The packing efficiency is maximum for FCC and HCP. So the answer is FCC. For a closed pack BCC structure of the hard sphere, the lattice constant A is related to the sphere of the radius r. So they have asked the relationship between A and R for BCC structure. The relationship for A and R for BCC structure is root 3A is equals to 4R. That means A is equals to 4R by root 3. A is equals to 4R by root 3. The packing fraction of the simple cubic lattice is, so the packing fraction for simple cubic lattice is 52% or simply 0.52%. In a BCC lattice with the lattice constant A, the body centered position from the origin is at the distance of. So they have asked the same question about the relationship between A and R for BCC. Root 3a is equals to 4r, or r is equals to root 3a by 4. Root 3a by 4. When the molten zinc is cooled to a solid state, it crystallizes to HCP structure. The number of nearest neighbor of the zinc atom will be, so the number of nearest atom is nothing but the coordination number. So the coordination number for HCP and FCC is 12. A substance AXBY crystallizes in FCC lattice, in which A atoms occupy each corner of the cube. See, A atoms occupy corner of the cube and B atoms occupy the center of each face of the cube. So B atoms occupy center of the face. We have to remember something. There are 8 corner atoms whose contribution is 1 by 8. There are 6 face atoms whose contribution is 1 by 2. There are 12 edge atoms whose contribution is 1 by 4. And there is one body centered atom. Body center atom whose contribution is 1. So we have to remember this. See, now they have asked A occupies corner of the cube. That means there are 8 corner atoms. Its contribution is 8. That means 1. And B occupies the center of the face. So B, there are 6 face atoms because B occupies the center of the face. That means it has 6 face atoms which occupies 1 by 2. That means 3. So the answer is A1 and B3. A1 and B3. The total number of Na plus and Cl minus ions per unit cell of NaCl is, see, NaCl crystallizes into FCC structure. So this is an FCC face centered cube. For face centered cube, we know that there are 8 corner atoms and 6 face atoms on each face of the cube. They have asked separately for sodium ions and chloride ions. So if we consider sodium, Na plus, it crystallizes into FCC structure. So 8 corner atoms. So there are 8 corner atoms whose contribution is 1 by 8, plus there are 6 face atoms whose contribution is 1 by 2. So it's 2, 3, 1 plus 3. So the sodium atoms, there are 4 sodium ions per unit cell. If we consider chlorine also has 8 corner atoms whose contribution is 1 by 8 plus 6 face atoms whose contribution is 1 by 2. So this also has 1 plus 3, 4 chloride ions per unit cell. Therefore Na plus Cl minus, which is equals to 4 plus 4, which is 8 ions per unit cell. So the answer is 8 ions per unit cell. The crystal unit cell with the parameter A is equals to 3.1 angstrom, B is equals to 3.1 angstrom, C is equals to 5.2 angstrom, and alpha is equals to beta is equals to gamma equals to 90 degree. See, from here we can see that A is equals to B, but C is not equal to A and B. So there is a table here according to which we can see that it is a tetragonal structure. Also in this question they have asked about NaCl. There is something we need to remember about some different structures like cesium chloride, NaCl, zinc sulfide, KCl and diamond. Cesium chloride is a simple cubic structure. It crystallizes into simple cubic structure. Rest of these NaCl, ZnS, KCl and diamond, these all crystallizes into FCC structure. We have to remember this. And for simple cubic there are 2 ions per unit cell, and for the rest there are 8 ions per unit cell. Okay, the rest of the questions will be in the next video. Thank you.